Hello and welcome. In this video tutorial, we're going to help get through the fan cart physics Gizmo lab. Now, while I'm not going to be answering the questions for you, what I will be doing is going through the different parts of the experiment to show you how the interactive part of the lab will function and work. It is up to you to work the lab along with the video tutorial if you feel you're stuck, and then answer the questions accordingly. Please remember to pause and rewind the video as you need to. Let's begin. To start off, you notice that we are taking a look at the following vocabulary items: acceleration, force, friction, mass, Newton, Newton's first law, Newton's second law, Newton's third law, and velocity. We always start any Gizmo lab by taking a look at prior knowledge questions. Let's read them together so that you may attempt to answer them. Number one, imagine pulling a horse pulling a cart. What would happen to the speed of the cart if several bags of cement were added to the cart? Number two, suppose more horses were hitched to the same cart. How would this affect the speed of the cart? Please pause the video for a moment and answer each of those questions to the best of what you feel might they be answered. Okay, read along with me. Although these questions may seem simple, they form the basis of Newton's second law of motion. The fan cart physics gizmo can be used to illustrate all of Newton's laws. So before we begin studying Newton's laws of motion, and we haven't even really begun to study what a force is for that matter, we're going to see how forces can cause things to go either no motion, constant velocity motion, or constant acceleration motion. It's going to be one of the three. And this particular Gizmo lab will help us illustrate all three of those. Gizmo warm-up. The fan cart physics gizmo shows a common teaching tool called a fan cart. Place fan cart A on the cart, turn it on by clicking the on-off button. So you can say we're going to take a fan, put it on here, and then we're going to click the on button, right? And you can see that it's got air blowing right to the left. Number one, look at the blue lines coming from the fan. In which direction is the air pushed? Right? Go ahead and answer what you see. Number two, press play, observe the cart. In which direction does the cart move? You can see the cart moving down below. And number three, once we click reset, we're going to select the bar chart tab and click play. Does the velocity change or stay the same? The bar chart tab is right here. Click play and answer question three. A change in velocity is called acceleration. Activity A, Newton's first law. We're going to click reset and we're going to remove all fans from the cart. Number one, form hypothesis. What will the motion of the cart be when there is no force acting on it at all? Okay, and then we should note that there is no friction in this model. Please take a moment to answer question number one. Okay, so again, before we start with question number 2, remember you are advised to pause the video as you are answering the questions and then resume the video when you feel you need help along the way. Part 2, predict. Suppose a cart with no fans has a starting velocity of 2 meters per second. What will the velocity of the cart be when it reaches the wall? Again, make your prediction for part 2. Okay, now that you've made your hypothesis for part 1 and your prediction for part 2, let's experiment and find out what happens. Here's what you will do. You are going to make sure that there are no fans on the cart. On the description tab, you're going to set the initial velocity to 2 meters per second, and then you're going to select the bar chart and click play. Okay, we have no fans. For the description tab, we're going to set the initial velocity to 2 meters per second, slide it all the way over, and then you're going to select bar chart again. Click play, and you'll notice that although the displacement went from 0 to 12, the velocity, and I'll play it one more time, remained the same as it started at 2 meters per second. Part 4, experiment. Click reset, place 2 fans on the cart and point them in opposite directions. Okay, so we're going to put fan A and then we're going to put fan B on top. Now to switch the direction of fan B, just go ahead and click fan B from a plus to a minus. And you can see fan A and B are just pointing in opposite directions. Okay, turn on both fans, click play. Okay, click play and observe what happens. What did you notice about the velocity of the cart? Please pause and record your observation. Part 5, select the graph tab. What do you notice about the graph of position versus time? The graph tab is the far tab over to the right. You'll notice that not only does the cart move at a constant 2 meters per second, we can see that we end up with a straight line with a constant slope. And if you were to examine the slope has a rise of 2 meters for a run of every 1 second, corresponding to the 2 meters per second of velocity. Part B, what do you notice? What does the graph of velocity versus time show? So here's position versus time. You can get velocity versus time by using the pull down menu and just selecting a velocity versus time graph. And you'll notice that for 5 seconds, what do you see here? A horizontal line at 2 meters per second. Part C, what do you notice about the graph of acceleration versus time? Now that's one we haven't explored yet in any of our labs or activities. So let's take a look. Switch this over to acceleration versus time, and there you go. You'll see it. For 5 seconds, it's showing 0 acceleration, right? All along the t-axis is 0 acceleration. So constant velocity means you're not accelerating. And we're representing that by showing 0 acceleration on the graph. Part 6, draw conclusions. Newton's first law states that an object in motion will travel at a constant velocity unless acted upon by an unbalanced force. How do these experiments show this? Please take a couple minutes to answer question 6 above. Pause the video and resume when you're ready. Okay, well, that concludes activity A. Scrolling on, let's take a look at activity B, Newton's second law. I'm going to reset and put the fans back where they went. There we go. We want the initial velocity of the cart to be at 0. So we're going to set this tab all the way back to 0. Place all 3 fans on the cart, all blowing to the left. So we're going to put A, B on top, C on bottom, turn them all on. You can see all the fans are blowing to the left. Scroll to the bottom of the table. What is the final velocity of the cart? Well, we have to click play and then select the table tab. Okay, so let's click play. You can see the cart is gaining velocity, right? Therefore, it's accelerating. We're going to go to the table tab here, scroll all the way down. Oops, sorry. Scroll all the way down to the bottom here, and you can see the final velocity that the cart reaches at the end of when it hits the wall is 4.9 seconds. Okay, go ahead and record that right here. I'm sorry, I misspoke. 4.9 meters per second. That's a velocity, not a time. How long did it take to reach the end of the track? Well, you can see the speed was 4.9 meters per second. The time was 4.08 seconds. So by scrolling down to a certain place in the table, you can get the final values if you scroll all the way to the end. Part 2, calculate. Acceleration is a measure of how much velocity the cart changes each second. To calculate acceleration, divide final velocity by the time it took to reach that velocity. The units are in meters per second or meters per second squared. Please take a moment to take the final velocity of the cart divided by the time that it took to reach that cart and record your answer here. Please make sure you include the proper units of acceleration. Okay, now that you have an acceleration calculated, let's go to the table and check. When we go to the table and check, you'll notice that the acceleration matches with your calculation of 1.20 meters per second squared. Hopefully you were correct on that. Part 3, form hypothesis. Let's read part A and B together. How do you think changing the mass of the cart will affect its acceleration? Part B, how do you think the number of fans will affect the cart's acceleration? Please pause the video and take a few moments to write good quality sentences predicting what you think will happen when you change the mass and what you think will happen when you change the number of fans. Okay, experiment part 4. Let's see how this works. We're going to select the bar chart, and we have a controlled experiment here. First, we're going to start with 3 fans, only one of which is turned on. So I'm going to clear 3 fans, only going to turn on A. Okay, what you're going to do is you're going to press play, and you'll notice that the acceleration, right, you can see what the final velocity is when you reach the wall. 2.83, takes 7.0 seconds to get there, but you'll notice the acceleration is 0.40 meters per second squared. Go ahead and record that here under the first trial. The second trial, you're going to have 3 fans on the cart, but now you're going to have 2 of them turned on. You're going to record that observation here. The third trial, you're going to have 3 fans turned on, all 3 of which, so 3 fans on the cart and 3 fans turned on. You'll record the acceleration right here. Okay, now that you have accelerations plotted, or excuse me, recorded for 1 fan, 2 fan, and 3 fans, let's see what happens when we have all 3 fans on the cart, but we change the mass units. So we're going to load 2 mass units onto the cart. We're going to make the cart heavier, and we're going to keep the same exact type of experimentation. We're going to have 1 fan on, then 2 fans on, then 3 fans on. Okay, so let's go back. Okay, we will start with 1 fan on, right? Let's load 2 block units inside the cart. We're making the cart heavier now. Okay, go ahead and press play. You'll notice the final velocity is less, takes longer to get there. That's because the acceleration is 0.20, half as much as the 0.40 we saw in the first experiment here, the first trial. So 0.20 meters per second squared is the acceleration for the first trial. Again, 3 fans, but only 1 turned on. Repeat the experiment 2 more times by having 2 fans turned on, and then finally 3 fans turned on. Pause the video and complete your part of the experiment. Okay, let's take a look at some results. Part 5. You're going to have to look at your data table to answer questions 5. Part A. How did doubling the force affect acceleration? I'll give you a hint. Take a look at the second trial with 2 fans turned on as opposed to the first trial with only 1 fan turned on. Part B. Compare the first and third lines of data. How did tripling the force affect the acceleration? And then finally, part C. A cart with 2 mass units and 3 fans has twice the mass of the cart with just 3 fans. How did doubling the mass affect the acceleration? Now, to answer part C, you might want to compare 3 fans turned on with no mass units and then 3 fans turned on with 2 mass units. I would compare rows 3 and row 6. Please pause and finish part 5. Part 6, draw conclusions. Newton's second law states that a force is equal to mass times acceleration. This can be arranged as acceleration equals force divided by mass. How does this experiment demonstrate Newton's second law? That a net force causes a mass to accelerate. Please pause and finish part 6. Part 7 is a challenge question. To answer part 7, you might want to experiment with the gizmo itself and put different combinations of forces in and masses and try and figure out what the mass of the cart, the mass of the fan, and the mass of one of those mass units that you drag on to the cart would be. Do your best on part 7. It is a challenge for that reason. Once you are done, please go ahead and click Turn In and submit the lab.